I'm explaining homework number 3. So 3.2c, during the steady heat conduction, the rate of heat transfer into the wall is equal to the rate of heat transfer out of it. But when it's a transient heat, it's different and it's not the same because the temperature along the wall is changing with the time. 310C, we have two cans, one wrapped in the blanket and one is like on the table. So the blanket will introduce additional resistance due to the convection. So heat transfer from the wrapped blanket surface is less. So the one that without blanket on the table is like warm up faster. On 324, we have a glass wall and so we calculate the area first, and after that, Ri, R glass, and R0, that is like R convection 1, and R glass, and R convection 2, and adding them together, and Q dot is the T infinity 1 minus T infinity 2 divided by the total resistance, and we get the steady rate of heat transfer. And it wants us to find the inner surface temperature that we put it on the formula on the only like first wall, the R convection 1, and find the inner surface temperature. Next question is question 373. Is that wall with the layers of sheet rocks and space filled with fiberglass. So we calculate the area and Ri, R1, R2, R3, R1 and R4, that is our sheetrock is the same, and R3 is our fiberglass, and there's our meat that is R2 and R3 because they are in parallel together. So we calculate the total resistance, and again we find the Q total with T infinity 1 minus T infinity 2 divided by the total resistance. The next question is question 394. That is the question that a hot water average temperature of 90 degree going through a pipeline, and it wants to calculate the heat rate transfer and the surrounding temperature and like the mass rate, stuff like that. So we calculate the two different areas, inner and outer, and calculate the resistance, Ri, R pipe, and it has a radiation that we calculate the H radiation with the formula, and we calculate the total resistance again, calculate the heat transfer in the steady state, and after that calculate the mass rate and volume rate. And at the end, it wants us to calculate the surrounding temperature that we like calculate with that last formula right here. The next question is 1455. It wants us to have all the terms defined and like all the formula, heat conduction, that I have all the formulas together. 1456 is the true-false question that is A is true, B is false, C is true, and D is false. So I'm not going over them because the time consuming. And 1457 is the mass transfers question, the plastic membrane separator, the hydrogen from air, and asks to do the molar concentration when there's a 2 millimeter and there's like 0.5 millimeter like membrane there. And here's the formula for that. Thank you so much.